we're in 2-1, and we're going to look at some of the very, very basics. So 2-1 is primarily a review. And we're going to begin by talking about ordered pairs. And ordered pairs, well, they go x, y. Okay, and we're just going to begin, again, with a little bit of review about how to plot points. So let's plot the following ordered pairs. And let's say we plot -3, 4. How about 5, -1? And how about 0, +4? So we're going to plot these points. Now, when we plot them, all that means is we just put a dot where they belong. Okay, we're going to plot these ordered pairs. We're not going to connect them together. When we say graph, they get connected together. And remember, this is your x-axis. So this is positive x, this is negative x, and this is positive y, and this is negative y. All right, we just got started. Yep, you're welcome. Okay, so we were just talking about ordered pairs. We hadn't really covered anything at all yet. All we were talking about is 2-1 and the very beginnings of ordered pairs. And ordered pairs, remember, go x, y, and we're just learning how to plot these ordered pairs. So we'll just plot these quickly. So if I wanted -3, +4, well, that's back 3 units and up 4. And that puts our first ordered pair right here at -3, 4. If I look at 5, -1, that's over 5. And that's down 1. So that's right there at 5, -1. And then if I look at 0, 4, that's 0 there at the origin. And we're going to go up 4 units, and that would be 0, 4 there. So ordered pairs, they go x, y. Okay, and then when we look at our Cartesian plane, remember x goes left and right, y goes up and down, and x is always first. And so that's how we plot these ordered pairs. Now next, let's learn how to graph equations by creating ordered pairs, by filling in the missing ordered parts of an ordered pair. And then we'll talk about the distance and the midpoint as well after that. So we're going to go ahead and graph this equation by completing the ordered pairs. So we'll start off with something pretty easy. So we'll do 2 of these. How about y equals -3x plus 5? And I'm going to give you some ordered pairs. And I'm going to have you complete these ordered pairs. So how about blank, comma 5? How about 1, comma blank? And how about -2, comma blank? So we're going to go ahead and graph. Move this a little bit here. Get this adjusted right. We're going to go ahead and graph this line, y equals -3x plus 5. And we're going to do this by filling in the ordered pairs. Now in the next section, we're going to learn how to do this without using ordered pairs, but using the slope and the y-intercept. But in this section, we're just going to remember how to complete these ordered pairs and graph our line. Now to graph a line, we need at least 2 different ordered pairs. In this case, we've got 3, and that's more than enough. So we'll start with our first one, and we're going to plug in y equals 5. And if I plug in y equals 5, we need to then solve it for x. So we're going to plug in y equals 5 here. And what does that give me for x? Well, if I move that 5 over, that gives me now 0 equals a -3x. So divide by your -3. And that gives me now x equals 0. So my first point is 0, 5, and that's going to be called your y-intercept. Because whenever your x value is 0, you have a y value, that's your y-intercept. Let's do the next one. How about in the next one, we're going to plug in x equals 1. So there's x and there's y. So we're going to plug in the 1 for x, and we're going to find our value for y. And if I do that, that gives you then minus 3 plus 5, and so that's a y equals 2. So there is my second ordered pair at 1, 2. And then my last one, x equals negative 2. Now watch your signs here. Bless you. And watch your signs, because a negative times a negative makes it a positive 6. And 6 plus 5 is then 11. Okay. Hopefully everyone kind of remembers how to do this. This is just some of the very, very basics. And then once we have these ordered pairs, then we can graph them, right? We can plot our points and we can graph the equations, or the equation. Now, if they're lines, they should make a straight line. So let's go ahead now and plot our points. And we're going to begin with 0, 5, and that's your y-intercept. So that's at 0 and up 5. Our next one is at 1, 2, so that's over 1 and up 2. And then our next one is back 2 and up 11. So there's 5, 6, 7, 8, 9, 10, 11. So that's going to be clear up here at minus 2, 11. And now we just connect them together and we make our line. And these are all going to be lines, so no curves yet. We'll talk about nonlinear functions and curves in a later part of this chapter. The first half is nothing but lines. And so we completed our ordered pairs, and we graphed our equation. Okay, let's do one more, and then we'll talk about the distance formula and the midpoint formula. So let's do one more of these. So let's go ahead and graph the line by completing the ordered pairs again. And we'll just do two of them in this case. We're going to do our intercepts. These are called our intercepts. We're going to go ahead and fill these in. And sometimes you may get a fraction. And if you get a fraction, what we do is we kind of figure out about where that point belongs, and we try to graph it to the best of our ability. Because not always do you get whole numbers. Most of the time you do, but in some cases you may not. Now you need at least two different points, two distinct points to graph this line. So let's start with x equals 0. And so if I plug in x equals 0, then we get minus 4y equals 2. We divide by our minus 4, and we reduce that, and we get y equals minus 1/2. So there's that. Is everyone okay with that so far? And this is something I'm sure you've done many, many times before. And for the next one, we're going to plug in y equals 0. And that's going to be our x-intercept. And 4 times 0 is 0. So now we have 3x equals 2. Divide by our 3. And now we've got x equals now 2/3. Okay. All right. Yeah, I got your message, Tracy, so glad you're able to make it here.
And my take husband's car.
Okay. And we just got started. We're just in 2-1. So all we went through so far is ordered pairs. Now, how do we graph these ordered pairs with fractions? Well, the way we graph them is we kind of approximate where they belong. They're not going to be exact. If we wanted an exact graph, we would use a computer or a graphing calculator. When we graph, we're just kind of getting a sketch of what it's doing. So when I go to graph these, our first point is 0, minus a half. And that's pretty easy with the minus a half, right? Because a minus a half is in between 0 and -1, and right in between. So 0, minus a half, your x is at 0, and you're going to go down about a half of a unit. So it's going to be right about there at 0, minus a half. And that's, by the way, called your y-intercept because that touches the y-axis. My other point is 2/3, 0. And what do we know about 2/3? Well, 2/3, if we look at it as a decimal, and we just go to one decimal place, that's 0.7, right? And so when we talk about 0.7, well, it's between 0 and 1, and it's a little bit closer to the 1. So we'll put that right about there. And that's 2/3, 0. And now we can connect them together, and we can graph our line. So they're not going to be perfect graphs. They're just sketches. When we graph, we just kind of sketch the graph. And so it's going to be a line going upward. And all of these in 2-1 are all lines. So they're not going to be anything that's going to be a curve. They're all going to be lines. Now, what we can do with ordered pairs is we can also find the midpoint, and we can find the distance between two ordered pairs. Now, the midpoint I'm sure you're already familiar with because we did this in previous courses. And it's, again, very, very simple to do. So when we talk about our midpoint, our formula is simply x1 plus x2 over 2 and y1 plus y2 over 2. So that's going to be our midpoint formula. All we do is we add the x's together, and we divide by 2. We add the y's together, and we divide by 2. Okay, so I'm going to give you two ordered pairs, and we're going to find the midpoint. So I'm going to give you points P and Q, and I want you to find the midpoint. So I'll give you the point P. How about minus 3, 5? And Q, how about 4, negative 1? Very, very easy. Very, very straightforward. We label x1, y1, x2, y2. I always like to write my formula down. I think repetition is one of the best ways to learn these. And so that's x1 plus x2 over 2, and y1 plus y2 over 2. We fill it in, and we get minus 3 plus 4 over 2. And we get 5 minus 1 over 2. We just combine minus 3 plus 4, well, that's a 1 over 2, so that's a half there. And 5 minus 1 is a 4. 4 divided by 2 is a 2. So that is going to be your midpoint. So very, very simple. You just add the numbers together and divide by 2. If they're decimals, they work the same way. If they're decimals, you can write your answer as a decimal. If they're not, you'll leave them as a fraction, like these. So let's try one with decimals. So let's say P is going to be, how about 8.1 comma minus 3.2. And Q is 4.7 comma minus 1.9. And don't try to make these harder than what they need to be. We just add everything together on the x's and the y's. And so x1, y1, x2, y2. And my midpoint formula is x1 plus x2 over 2, and y1 plus y2 over 2. So we'll plug our values in, and that's 8.1 plus 4.7 over 2, and minus 3.2 minus 1.9 over 2. And then we just add those together, and then divide. So 8.1 plus 4.7, well, that's a 12.8 over 2. And a minus 3.1 and a minus 1.9, that's a minus 5.1 over 2. And then we just divide them through. And that comes out to be a 6.4. And 5.1 divided by 2, well, that's a minus 2.55. So very, very simple on these. 2-1 is a very quick, easy section to go through. Now, what is that? Well, this is our midpoint. And what does that mean? Okay, if I've got 2 points on a map, let's say I'm trying to have some kind of conference between two people and they're on at two different cities. So I want to figure out where can they meet so that it's about halfway in between. Well, you could find your midpoint because x and y are represented by the longitude and the latitude. And so you could actually, if you got your coordinates of the two individuals, you could actually run through the midpoint formula, come up with an ordered pair, and that would be your longitude, latitude coordinate, and where you should try to hold that meeting at, or pretty close to it. So it kind of gives you an idea of what's in the middle. That's all the midpoint is. It's just right in the middle. Now we can also work backwards. I can give you an endpoint and a midpoint, and you're going to have to go back and find then the other endpoint. So we're going to be given P and the midpoint. I want you to find Q. So we're going to be having to find Q. So P, we'll just say that's going to be the point 3, 5. And we've got a midpoint. And you could use an M for the midpoint, or you could just use an or an M, capital M. So you can write out midpoint and use a capital M. Let's say our midpoint is minus 8, 1. And we don't know Q, so I'm going to give Q the ordered pair XY. Okay, so we're going to go ahead and find this. And I didn't even give you a homework question over this one, but you've seen it before in intermediate, and so I think we should at least look at one of these. Now, how does it work? Okay, well, we got to plug things in. So P is going to be x1, y1. Q is x2, y2. And this is just a really good exercise in using the formulas here. So here's our ordered pairs. Now, what's our formula look like? Well, our midpoint formula is x1 plus x2 over 2 and y1 plus y2 over 2. In this case, what we know is we know the midpoint already. So the midpoint is minus 8, 1. So that's our given. And that's going to equal now x1, which is 3, plus x2, which is x, over 2. And y1, which is 5, plus y, because that's y2, over 2. Now, we are going to have to solve two equations, but they're very easy to solve. And we're going to end up with our x and our y components of our q. So this is your x, and this is your y. And let's look at the x part. And so the x part is everything in front of the comma. So we have a minus 8 equals 3 plus x2 over 2. Right, that's your x part, everything in front of the comma. How would we solve this? Well, there's not much to do. We can cross multiply. And so that gives you then a minus 16 equals 3 plus x. We'll move our 3 over. And so we know now x must equal a negative 19. So that's all we have to do. What about the y part? All right, well, the y part is everything behind the comma. So this is going to represent our y part here. And we've got 1 equals 5 plus y over 2. So we just simply cross multiply again. So 2 equals 5 plus y. We move our 5 over. And so now we've got y equals, in this case, a negative 3. And so what's our answer? Well, our answer is going to be that point Q. And Q is minus 19, comma, minus 3. And I know you've done those before. I didn't even give you one in the homework about it, but I just want to go over one of these. I know we did these in intermediate. The only new part in 2-1 is the distance formula. And it is not that difficult either. And the distance formula is simply d equals the square root of x1 minus x2 squared plus y1 minus y2 squared. You don't have to worry about any fractions with these or decimals. They're all going to be whole numbers that I'm giving you for the distance formula. Now, what we have to remember about the distance formula is we square it. When we square a negative, what happens? It becomes a positive. Okay? And we subtract them first. We do our parentheses first. So this is the only new part. Now, once we get our square root, we may have to break it down. We don't want these as decimals. We want to keep the square root as itself. So, for example, if it was 8, square root of 8, you'd break it down into 2 square root of 2. So let's go ahead and find the distance. And let's say Q is 5, negative 1, and point P is 8, 3. And I want you to find the distance here. So x1, y1, x2, and y2. And here's our formula. Now, when we work this out, we have to be very careful of double negatives. If we have a double negative, that's going to make that a positive value. So we have to make sure that we're really careful with our numbers. So what do we have then? Now if we plug our values in, we have d equals the square root. We're going to plug our numbers in of 5 minus 8 quantity squared plus minus 1 minus 3 quantity squared. And so then we just square, subtract, we square, and we're done. So let's do our parentheses first. So 5 minus 8, well, that's a minus 3. And minus 1 minus 3, that's a minus 4. We still have to square these. 3 squared is 9. 4 squared is 16. And we're lucky in this case because when we add them together, we get the square root of 25, which is then simply a 5. And this is the shortest path between these 2 points. So if these are 2 cities on a map, the absolute shortest path you could take would be, in this case, like if it was miles, 5 miles. If these were cities located on a map, longitude and latitude, that would come out to be 5, and that might be the shortest absolute possible distance. One more, and then we'll move on to 2-2. And we're going to get through several sections today because they're so quick to move through. There's really not much in these. So let's find the distance again. And let's say we've got P of minus 8, 2, and Q is minus 3, minus 7. So let's write up our formula. So we subtract the x's, square the result, subtract the y's, square the result, and then take the square root at the end. And make sure you label x1, y1, x2, y2. So plug these in. And we've got minus 8. Minus, now again, we have to be very, very careful about the double negative. So it's minus 8 minus a minus 3, quantity squared. And then we've got 2 minus a minus 7, quantity squared. So when we have these double negatives, we have to be careful because that double negative here and over here, well, that's going to make that positive. And now we've got minus 8 plus 3. Well, minus 8 plus 3 is a minus 5. We're going to square that in a moment. Now on the other one, we've got positive 2 plus 7. That makes it a 9. And whenever we square a negative, that makes that a positive. So that's 25, and 9 squared is 81. And we add those together, and we get the square root of 106. Now we always have to check because that square root, it might break down. So we break them down if we can. 106 is an even number, so let's try a 4 to begin with. 4 doesn't go in there, but I'm sure that a 2 will. So 2 and 51, and I don't think we can really do much else because 51 breaks down to 3 and 17. Okay, and that's about it, right? Do we have any pairs at all? No pairs. So that means my distance then is simply going to be the square root of 106. That's it. Right? Won't break down anymore. That's all we can do with it. That finishes up 2-1. And there's very, very little in 2-1. The only thing that's new is the distance formula. You should have already seen the midpoint from last semester or previous courses. I know you've seen how to plot points many, many times before. So that was all review. The distance is the only new one. And now we're going to move on to 2-2. And we'll get through a little bit of 2-2 and then we'll take a short break. 2-2 is completely different. It's something brand new. 2-2, we're going to look at circles. Okay, and for circles, there's two things that we need. To graph a circle, well, we need a center and a radius. So for circles, we need a center and radius to graph it. Now, if you remember back from grade school and maybe middle school, you worked with the compass, right? And that compass, you had the point and you had the pencil on the end, and you could adjust the length back and forth, and then you spun it around, right, and you made a circle. Well, that's a circle, and that had a center, and that center is where the point was in the compass, and the radius is how far the point on the compass was from the pencil on the end. So when you spun it around, it made a circle. So we're going to need a center and a radius when we go to graph these circles. So first I'm just going to give you a center and a radius, and we're just going to graph the circle. So we're just going to graph this circle, and I'm going to give you a center at, how about, -1, 3, and a radius of 3. Okay, so we want to graph this circle, and we've got a center, and we've got a radius. So how do we go about doing that? Well, the first thing we do is we take our center, which is an ordered pair, and we find it. So the center is at -1, +3. So that's here. Now, what's the radius? Radius is 3. So that means that we go 3 units in each direction. So we're going to go 3 units up, down, left, and right from the center. So 3 units down, if we go down 3 units, is going to put it right about there. We're going to go 3 units forward, so 1, 2, 3. That's going to put another dot about right there. We're going to go 3 units up, so that's going to put a dot right about there. And then we go 3 units back, and that's going to put a dot about there. So there are 3 units in each direction, right? Now you just connect them together, and that makes your circle. So there is your circle. So 3 units in each direction. If your radius was 8, you'd go 8 units in each direction. Find your center first. Once you've got your center, make sure that looks like a 3 there. Once you've got your center, then you go 3 units in each direction. Make your circle, and you're done. Now let's talk about center radius form, and this is going to be the equation of a circle. So the equation of a circle is this. It's x plus h, quantity squared, plus y plus k, quantity squared, equals r squared. And your center is minus h minus k, and your radius is the square root of that r squared, so it's simply r. So what we need to do when we look at these equations is we got to remember we switch the signs, and then we take the square root of that number, because that's r squared, and we want r, not r squared. So I'm going to give you 2 of these, maybe 3 of them. We're going to find the center and the radius. We're not going to graph them. So we're just going to find the center and the radius. And then I'm going to give you 2 of them where I give you the center and the radius, and you come up with the equation. So we'll do it in both directions. And do not make this more difficult than it needs to be. I know this is brand new, but all we need to find here is we need to find our center and we need to find our radius. So when we find our center, what we do is we change our signs. So we just switch the signs around. So that minus 3, well, that becomes a positive 3 for my center. And that positive 2, well, it becomes a negative 2. And there's your center. And then your radius. Now your radius is not 16. Your radius is the square root of 16, which is then 4. So that's it. There's your center. And there's your radius. That's all you have to do. Switch your signs and take the square root of the number on the right-hand side. Not much to these at all. And again, we'll do 3 of these just to make sure we have it down, because they're easy but important. And then we'll do 2 of them where we go the opposite direction. Where I give you the center and the radius, you write the equation. Now, what's a little bit different about this one is when we look at the x part, well, we don't have a number with that x, do we? Right? So if we don't have a number there, we're just going to use a 0. So what would my center then look like? Okay, my center would be, there's no x number with that, so that's going to make it a 0. And then what about the y component? Well, it's not negative 9, it is a positive 9. And what is your radius? It's not 25. It's the square root of 25, which is then what? 5. So there's your center at 0, 9. And your radius is simply 5. And again, we're going to find the center and the radius. Okay, well, for the center, do we have an x number? Nope. Do we have a y number?
No.
Nope. So my center is now going to be at the origin at 0, 0. What about the radius? Well, the radius is not just 12, it's the square root of 12. Now, whenever we have these square roots again, we need to break them up if possible. And 12 breaks up into 4 and 3, and 4 is a perfect square of 2 and 2. So that square root of 12 comes out as 2 square root of 3. And there's your center, and there's your radius. And that's it. Now let's go the opposite. Now I'm going to give you a center and a radius, and I want you to find it in center radius form. So let's say we have a center of minus 3, 8, and a radius of 2. So what are we going to put here? Okay, the center is at minus 3, 8. Now, whenever you go from the center to the center radius form, or vice versa, whenever you go from one to the other, always change those signs for the center. So instead of it being a minus 3, it becomes an x plus 3. And instead of it being a positive 8, it becomes y minus 8. Now, when we went from the center radius form to the radius, we took a square root. So when we go from the radius to the center radius form, we have to square. So that's why that's going to be the 2 squared there. And now we can clean it up. And so our final answer in center radius form would be x plus 3 quantity squared, y minus 8 quantity squared equals now 4 quantity squared. And that's it. We'll do one more, then we'll come back and finish up this section. So same directions. Let's find the center radius form. And let's say our center is at 5, minus square root of 3. And our radius is the square root of 7. Okay, well, what's my center radius form going to look like? We always write it down with our parentheses and the squares. So we switch our signs, so it's going to be x minus 5 quantity squared. You always switch the signs when it goes from the center to the center radius form. And then y minus a minus square root of 3, so we'll switch that out. And what's the other side? Square root of 7 squared. So what does that give you? That gives you x minus 5 quantity squared. The double negative here makes that then a positive. So that's y plus the square root of 3 quantity squared. And then what about the right-hand side? When we square this square root, it becomes a 7. So there's your answer. In. Center, radius, form. So let's go ahead and take a short break. And we'll meet back here at, let's say, how about 9:55? So about a 10-minute break. We'll come back. We'll finish up this section. And we'll probably get done between 3 and 4 sections today, because there's not much to these at all.